Hello, today we're going to talk about the method of sections, which is another method to solve for the forces in a truss. So you should be able to determine the forces using the method of sections. That's today's objective. And of course the applications are numerous, because we not only can use this method for civil engineering applications, but other applications. Here you see towers and large cranes that also we can apply this method of sections. And sometimes we want to just determine a force in, let's say, in this structural element. If I use the method of joints, I have to determine joint after joint after joint until I reach that middle point. And so the method of sections will be helpful if you just want to determine a few forces in part of the truss. In the method of sections, of course, you basically cut a truss, and we will do the same assumptions as before, that we will assume that all the forces are in tension, and of course with the same magnitude of forces at the joint, and using equilibrium reactions, we will solve for the sum of the forces in X, sum of the forces in Y. But now with the method of sections, you can also use sum of the moments about any point. So basically, here's an example of the method of sections. We cut through this section, and for the free body diagram, you draw the forces, and they're coming out of this structural member, the thin member, and you assume tension, so it's being pulled out. And of course, whenever we had the method of sections, of joints, we had the force coming in this direction because the structural member was in tension. So now we have the structural member, and then we just assume away from the structure is in tension. So basically that's the minor difference, but the concept is the same. And for the free body diagram, of course, it's an imaginary cut, but you still have the forces that collide into one point, and you have to include all the dimensions, external forces, whether it's the right hand, so you have these two sections here, the right and the left. And so one of the decisions you'll have to make is which section is more convenient, and we'll talk about that in just a minute. So the steps for analysis is, first of all, you need to cut the truss, and you need to make a decision based on what forces you need to determine, and where the total number of unknowns does not exceed 3 in general. Remember that you can have more than 3, but then it is a statically indeterminate structure. So in this case, it's being cut through here because you might want to determine GF or GC or BC, the forces in those members. If I wanted to know the forces in CD or FD, then I could have cut it here. If I just want force AB, then I cut here, which is like a joint. So depending on what forces you will need to determine, and of course where the total number of unknowns does not exceed 3, decide which side of the truss will be easier to work, because you want to minimize the reactions. And let me show this here real briefly. In this specific case, where I have my cut in AA, I have this section to the right and this other section to the left. So if I choose the section on the left, I don't have to calculate the support reactions, because I'll be working just with the left side. But if I use the right hand side, then I have to calculate the support reactions. Here I have a roller, so it's in X, and here I have a pin, so you have in X and Y. So if I want to determine these 3 forces in those 3 thin members, then I better use the left hand side. But you cannot always prevent having to calculate the support reactions. And then, of course, you have to draw your free body diagram for the entire truss. If you have to calculate the support reactions, just like we did in the case of method of joints, that in order to calculate the support reactions, you use the whole structure before you cut it. Okay? And then after you calculate the support reactions, then you can cut your truss. So once you cut the truss, you just draw the free body diagram. You, as I said before, you have to indicate the unknown forces and the cut members. Assume that they're all in tension, just like you did in the method of joints. If the answer is positive, the member is in tension, and if it's negative, then the member is in compression, just like we did before. And of course, you apply the scalar equations of equilibrium to the selected cut section to solve for those unknown members. So let's see this specific case here, and I have my truss, and I have cut it through the section AA. So this is the free body diagram for my left side, and the free body diagram for the right side. So if I'm interested in knowing these forces, the decision is clear that I can just use my left hand side of the truss. Okay, so let's solve this truss real quick. And if I look at the left hand section, so let's focus on the left hand section. The first thing I could do is to determine FGF, and I'll give you a minute. You can pause it and think how we can solve this in the most efficient way. So if I do, and there's many ways of course, if I do sum of the moments at point Z equal 0, I can solve for the unknown FGF. So in this case it's negative because they knew it was going to be negative, but in your case you always assume that it's in tension, and we'll figure out what is the magnitude of that force and the direction, but for now we can leave it like that. Okay, so let's take a look at the calculations here. So I have the force of 1,000